Okay, welcome to the first day after spring break. We're going to continue Unit 5. First half of Unit 5 was exponential functions. So we're going to go over our rules of exponents since it's been a while since we had math class. So the first idea is that when we multiply two exponentials, or what we call product rule, we add the exponents, and when we divide or have a quotient, we subtract the exponents. So when we take a power, raise it to a power, where we kind of are, what we're multiplying here, these exponents. And when we have it multiple things inside of parentheses, we're basically distributing this exponent to both of them. And a very important one is that when we raise to a negative exponent, negative exponents do not make negative numbers, it makes reciprocals, 1 over b to the m, or a negative on top goes to the bottom, a negative bottom goes to the top, and we get something like this. And when we have a fraction as an exponent, they don't create fractions, they create roots. So b to the 1 over n is the nth root of b. b to the m over n is the nth root of b to the m, and b to the negative, that's a little negative sign, is going to be 1 over, the negative is the 1 over, the n is the root, and the b is the power. So that's the idea, is that the m is the power and the n is the root. And I tend to do roots first. So let's go through some examples. Well, I'm going to add exponents here. Don't forget there's a 1 here. So 1, 3, and 4 make x to the 8th. Here I'm going to subtract. 8 minus 3 is x to the 5th. Over here I'm going to distribute or multiply. I get x to the 20th. This I'm going to do the same thing, except I have to do it once, twice, 3 times. Don't forget to do it to that number 2. I get 4x to the 6th, y to the 10th. We're here, oh, the negative means I have 1 over x to the 8th. And let's see, if I do this in pieces, 2 over 4 is a half. X to the 1st over x to the 3rd is x to the negative 2. And y to the 5th over y to the 1st is y to the 4th. I want to write my results with only positive exponents, so when I'm done I get 1 fraction bar. I have y to the 4th on top. There's a 1 on top also, I don't need to write the 1. 2 is on the bottom, and x squared is also on the bottom. And with this one, I see a fraction bar. X to the 5th is on the top. X to the negative 5th is on the top. Now I go to the bottom, and y to the negative 3rd flips to the top. And now with this one, there's a couple ways to go. One way to go is to say, well, there's a negative exponent. Let me just flip this in to begin with, because that's what a negative exponent means. You take the reciprocal. And now it's raised to the positive 2, and I can just distribute all of these. Don't forget to do it to the 3. I get y to the 4th, 3 squared is 9, x to the 10th. And that is my final result. So I'm going to use my rules of exponents to simplify these expressions. And over here I can subtract the exponents. So I get 3 to the 2nd, or 3 squared, which is equal to 9. Over here I could rewrite it as 1 over 5 squared, because that's what a negative exponent means. So I get 1 over 25. Over here I could flip these guys, so it becomes 3 to the 3rd on top, 2 to the 5th on the bottom, and 3 to the 3rd is 27, and 2 to the 5th is going to be 32. Over here I could just distribute. I get 2 to the 4th, and 2 to the 4th is just 16. And on these next ones, oh, I see a fraction. That means I have to take the root, or the square root of 4, which is 2. That's a negative. I know it doesn't look as clear, but that is a negative. So that's going to be 1 over the square root of 4, which is equal to 1/2. On this next one, I see the top is a power, the bottom is a root. So I'm going to do the root first. So this is the square root of 4 to the 3rd. The square root of 4 is 2 to the 3rd, and 2 to the 3rd is equal to 8. And this last one, I see a negative exponent. That means I could flip the number if I want to. Sometimes I could do it later. I'm going to flip it first. I could rewrite it as 8 to the 2/3, which means I have to have a power and a root, which is going to be the cube root of 8 squared. And the cube root of 8 is 2 squared, which is equal to 4. I could always do the flipping later, but sometimes I flip first, sometimes I do roots first. I tend to do the powers later. So for these last set, I'm telling you what base I want you to do when you rewrite this number as a base with an exponent. So this first one I'm saying you have to use base 2. So I'm saying 2 raised to the what? We're going to fill in this box. Well, it's going to be 2 raised to, well, if it's 16 it would be 4. But since it's 1 over 16, it's going to be negative 4. And that's what we get, 2 raised to the negative 4. Now I'm going to use base 4, so I have to do 4 raised to the what? Well, if it was 16, it would be 4 squared, but it's 1 over 16, so it's negative 2. It's 4 raised to the negative 2. Next one is going to be base 2. I see a root. It's the third root, so that's the 1/3 power. Again, I see the same thing. For this next one, I got to use base 4. Well, I have a 16, which is a 4 squared, and I see a root, which is a 1/3, so it's 4 to the 2/3. 4 squared is a 16, and the denominator 3 is the cube root. Same thing here. I have a base 3 that's given to me. I see it's 1 over, so it's going to be negative. I see a root here, so it's 1/2. It's 3 raised to the negative 1/2. Same idea for this next one. I see a base 3 I have to use. Well, a lot of ways I can think about it. I see it's 1 over, so it's going to be negative. I see a root, which means it has to be a half, and I see 27, and I know 3 to the 3rd is 27. So I get 3 to the negative 3 over 2 to get that root. And these last couple, well, I know 5 to the 3rd gives me 125, so it's 5 to the 3rd, and I see a root over 4, so it's 5 to the 3/4. And this last one, I see a base 6 I want to use. I know 6 squared is my 36, so I need a 2 somewhere. I see it's a 1 over, so it's got to be negative. I see a root. So it's 6 to the negative 2/5 is how I could rewrite that problem.